Hey, hi friends, this is Varun Goda. Welcome to my YouTube channel. Today we will discuss about RAG, Retrieval Augmented Generation. Before starting this session, if you don't know about pre-training and the fine-tuning, please go and watch about those two topics in my YouTube channel. Then you can watch this video because those two are pre-requirement for this session. Yeah, let's get started. Uh, we'll start with the drawbacks of fine tuning techniques. Drawback of fine tuning techniques are let's say you have this LLM model. You take this as a base LLM model. You want to fine tune, you have to fine tune this LLM model, base LLM model, to convert it as a chart or instruct model, right? How do you convert this LLM model, base LLM model to the chart or instruct model? By the technique called fine, fine tuning. If you want to convert this base LLM model to the instructor chart model, you have to do the fine tuning on this base LLM model with high high quality question and answer kind of data. Correct, right? This is how you convert base LLM model to the fine base LLM model chart or instruct model by doing the fine tuning. Let's take this example. You have a document. You have a document. You have a document which is having question and answer, question and answer, question and answer. We have till some 100k of question and answer about about some security software. Correct, right? Let's say the first question one will be like how to how to reset a password. For this, we will be having an answer like go to settings, then to password, like this. And there will be another question: how to active or how to activate license. For this also there will be an answer. Like that, there will be n number of question and answer. Correct, right? I'm talking about this document about some security software related, and you have base LLM. Correct, right? You have a base LLM, and you want to convert this base LLM to the chart or instruct model on fine tuning upon this data about this security software related. You have fed this data to this base LLM model, and you have done the fine tuning, and you got chart or instruct model which is having having knowledge of the security software related. No, correct, right? You have taken this document, you have fine-tuned the base LLM model to convert it as a charter instruct model, and which will be having knowledge about now this security software related. Correct, right? Whenever you ask this LLM model, this chart model or instruct model, which is an LLM model, what it does, let's say if you ask this question, uh, the question number one, the question number one goes into this fine-tuned fine-tuned LLM model. It will answer the it will give a response as answer 1, right? If you give this 100th question, it will give the answer related to 100th question, because it has learned this information during the fine-tuning stage. It learned in the sense weights. It learned in the sense weights or parameters. Weights or parameters got updated during fine tuning the model on this software related security software related Q&A information data. In the sense, like it learns in the sense the weights and parameters will be got updated. Now consider, let me rub till here. Now you have asked this fine-tuned LLM model question like, which is not a part of this document during the fine-tuning stage. Let's say the question is it having face recognition feature? Here, if you ask this question is not a part of this fine-tuning stage, and this question is not there in this document during the fine-tuning. What does this fine-tuned LLM model does? It might give general answer, or it might hallucinate the answer. Correct, right? It might give a general answer, or it might hallucinate the answer. Here we are not getting the proper answer, right? With respect to our security software and related. What we have to do for that? We have to again fine tune this base LLM model on this new question. If again some new questions comes, again you have to fine tune this model. Again some new questions comes, again you have to fine tune this model, so that this will become costly and needs more effort. In order to solve this problem, they introduced a technique called RAG. You got it right. This is the drawback of this fine-tuning technique. Let me rub this. Now we learned about the drawbacks, right? What are the drawbacks? Like you can say costly, needs effort, and output might be output might be get hallucinated. Correct, right? To solve this problem, they introduced a technique called RAG, retrieval augmented generation. What we do in the RAG, correct, right? Let me explain the data pre-processing stage for RAG. You have the document, right? Some 100K question and answer, document, question, answer. What we're gonna do, we're gonna chunk this data into n number of chunks. Let's say we have 100K question and answer, right? Let's say we chunked it into 100K chunks, each question and answer into one chunk. Let's say question, answer, question, answer, question, answer. This is chunk 1, this is chunk 2, this is chunk 100K. Once we chunk this data, we have to convert these chunks into embeddings. Embeddings is nothing but a vector. Let's say this question 1 and answer is converted to an embedding. Similarly, question 2 and answer 2, question 3 and answer 3, all have been converted into embeddings like that till question and answer of 100K. It can be any value. It can be 1.1, 2.2, 3.8, 10.7. It can be positive or it can be negative. Like that, we'll be having for each question and answer, there will be embeddings created for each. Now we took the document, we converted it into chunks. For example, each question and answer as a chunk. Then we are converting those things into embeddings. Once we convert this data into embeddings, we have to store this data into vector database. Why in vector database? It helps us to do similarity search. I will explain where this similarity search will come. It will help us to do the similarity search. You got it right. How do we pre-process the data? We got this 100K question and answer kind of data. We converted each question and answer into chunks. Then we converted those chunks into embeddings. These are embeddings. We converted it as an embeddings. After converting it as an embeddings, we stored it in vector database because we have to do similarity search on this vector database. You got it right. Now we have this 100K data in our 100K question and answer data in this vector DB. Let me run this one. Now we have this data after pre-processing everything, chunking and converting to embeddings. We stored it in vector DB. Let's say this is after pre-processing. Correct, right? Once we process this data, after processing this data, we put into this vector DB. Let's say this all question answers now available in the vector DB. If the questions comes, let's say we have taken that question example, right? We took three questions examples, right? Two questions and examples. How do we reset the password and how to activate the license? Consider these two questions have been available with answer in this vector DB after doing some data processing. I said you right, the chunking, converting to embeddings and all. Now, if I want to use that, if I'm using that security software, I stuck and I wanted to ask a question to the LLM based chatbot, like asked a question. I want to, like not I want to, uh, how to, how to reset, how to reset password and how to activate the license. What we're gonna do, if this question comes, we are going to convert this into embeddings. Then we're gonna do similarity search of this embedding on this vector DB. Similarity search for this embedding which we got for the question onto this vector DB, it will give the response as uh, related information for our question. We have the response related to our questions from the similarity search, and we have this question. Now both of this content will be fed into LLM model so that it gives the proper response. Correct, right? Here we are getting the proper response without updating the model weights. In the sense, we are not spending so much money or effort on fine tuning the model. In the sense, we are in the sense we are not updating the model weights, right? Without updating the model weights, if you want to update the model weights, we need thousands of GPUs of cluster and all. But with this rack technique, we are getting the relevant information as well from the vector DB using simulated search, and with the response as well as with the question, we are going to feed it to the LLM model so that it was able to generate a proper response for us. Here also, here we are able to reduce the cost and the effort, right? Reduce the and cost and cost and effort we are able to reduce. But still, the problem hallucination, how it gets solved here. Correct, right? Here, let's say if you ask a new question, if you ask a new question, which is not there in this document and all, this vector DB is not there. If I ask a question like, does it supports face recognition? Here, for this question, it will do the similarity search over this vector DB. It might not find the relevant embeddings, right? Or if it was not able to find the relevant embeddings, or it get irrelevant embeddings, then we fed this irrelevant embeddings, and this is a support face recognition. This LLM also might give hallucinated response, right? Correct, right? Because neither of this document is not having this information, and this LLM which we are using is also generalized LLM, which is not fine tuned on our this data. Here also, here also, here also, hallucination happens. But overcoming this hallucination is as much as easier compared to this fine tuning. Here, if you want to avoid the hallucination, what you want to do, you just update this vector DB. You have to do this data processing, but this processing is not costlier, not costlier as much as fine tuning. Correct, right? Just you update your vector DB with the updated data, you are ready to avoid the hallucination. Correct, right? But in case of fine tuning, what you have to do, let me run this. But in case of, but in case of fine tuning, you have to again update the again update the model weights or model weights or parameters, like, correct, right? You have to update the model weights or parameters. In order to update this model weights and parameters, you need GPU cluster, which will be costlier, right? But updating the data into vector DB is not costlier as much as this GPU cluster and updating the model weights and all. So, if you want to create a chatbot kind of thing without not spending much uh, money and the effort, you can use RAG, which helps you to reduce the cost. Also hallucination of the output. Here model will not get hallucinated because you are giving a relevant information which is there in the vector DB. Correct, right? There also, if you fine tuned on the data, you might get the better response. But if new questions and new content comes, you want to again fine tune your base LLM model, then it will be a costly process. So if you just use the RAG and update the vector DB, both will serve the same purpose. Correct, right? Updating the vector DB is not that much costlier compared to the fine tuning technique which you use to update the weights. Correct, right? Yeah, this is what the difference between RAG and the fine tuning and what to use when. Yeah, that's it for today's session. If you like the content, please subscribe to my channel. Let's see in the next video. Thank you.